Hey, hi everyone. Today we are in the last stream of vCluster Friday for October, sorry, September, and I'm very excited to have Madhuri with us. And today we will dive deep into a lot of interesting things, but I will start with the introduction. So, yeah.
Yeah, thanks, Hrittik. It's super exciting to be here. I'm the founder of Elotl. We make nodeless Kubernetes, which is abstracting out compute nodes and compute clusters from a fleet of Kubernetes clusters. vCluster is the industry standard for virtualization amongst namespaces for Kubernetes. So we are very excited to explore managing a fleet of vClusters in this webinar. So thanks so much, Hritik, for being open to trying it out.
Yeah, and thanks for joining in. So, I'm Hrittik, and I'm a product and platform advocate at vCluster. And the goal of vCluster Fridays is to meet all the awesome projects that are happening in the cloud native ecosystem and bring them together so that we can explore things and see how awesome the ecosystem is and how we can advance the entire ecosystem together as a community. So, Madhuri, so where are you based out of?
We are a fully distributed team. I'm based out of San Francisco Bay Area, where I know a lot of vCluster folks are as well. But like most other projects in the cloud native ecosystem, we are a fully distributed company and product.
Yeah, and that is so awesome about it because you can have people contributing to the projects from across the world, and all this consumption is happening around the world. So the goal is to have distributed compute, but it's so awesome that the distributed compute comes from distributed team across the world. So all the contributions, all the community is distributed as well. So how we talk about Nova today. So Nova is getting popular into the ecosystem, and this is our first time interacting with vCluster Friday as well. So would love to know what is Nova and how it is helping the community.
For sure, yeah. So Nova's vision is to commoditize clusters for users of clusters. As Kubernetes became de facto standard for platform across enterprises, initially people started out with pet clusters. So when people started adopting Kubernetes, they would have one, two, or three pet clusters. But as Kubernetes became the de facto standard, now there are tens of hundreds of clusters for trial environments for dev, staging, and production, managed by various teams. So Nova's vision is to commoditize fleet management of these clusters. So you do not have to hand manage each of these clusters as pets. We can move from pets to cattle concept. So we can manage these fleet of clusters as a single supercluster, and the user will define policies for scheduling which impact where your application lands. Taking it one step further, as a vCluster becomes the de facto standard for team and namespace management, we want Nova to be able to manage a fleet of vClusters as well, so that users provision as many vClusters as they need for team management, and the applications can automatically get dynamically scheduled to the right vCluster based on the operator defined policy, if that makes sense.
Yeah, of course. And if I may ask, so what are the biggest trends you are seeing? And second question is, what are the type of size of organization who require cluster management at scale? So is it like a startup with couple of clusters, or is it more geared towards like big enterprises where hundreds of node plane and control planes are running?
That's a really good question, Hritik. So, our original vision was it is a product that is a really good fit for large enterprises with large number of cluster footprints. But we have had interest in Nova from smaller companies as well. For example, a small startup that has a trial environment that is being provisioned for each customer, pretty quickly in a span of 3 to 4 months, their trial environment clusters went from 2 to 3 to over 100. So the moment your trial environments get to be over 100, then it becomes really hard to manage them by hand. And this is a small Series A startup. So we originally built Nova for enterprise scale and enterprise grade, but we see a good fit for smaller companies as well. And this really maps well to the vCluster vision as well, because instead of provisioning individual clusters for trial environments, if people can provision vClusters, that will make their life even more simpler. Does that answer your question?
Yeah, of course. And while going through the docs and everything, there is a concept of Nova agent. So what does the agent do? Like where does the agent sit, and what are the things that the agent takes care of?
Yes, yeah. Nova agent is Nova's agent that is running on a workload cluster. So Nova has this concept of a fleet of clusters that Nova manages. So each member of the fleet is a workload cluster. Any cluster can join Nova as a workload cluster. So it could be a cluster that is running OpenShift on-premise data center, or EKS or GKE, OKE, AKS, any of the cloud provider clusters, or any of the hyperscalers or the neo clouds too. For example, if you have a CoreWeave Kubernetes cluster or a Lambda Labs Kubernetes cluster. So for a workload cluster to join Nova's control plane as advertising itself as a workload cluster, Nova agent is the one that is deployed on the workload cluster that marks it as a potential candidate for Nova to be a part of the fleet of Nova's managed clusters. So extending this concept to vCluster, so any vCluster, as long as a Nova agent is dispatched to the vCluster automatically becomes a workload cluster candidate for Nova. Does that answer your question?
Yeah, of course. And if I may double down on the question. So is it that you should have a cluster at start, or does Nova helps you to create clusters as well?
That's a really good question. So Nova has this concept called just-in-time clusters. So
Mm-hmm.
you do not have to start with a pre-provisioned cluster that is always on, because if you're thinking about the legacy Kubernetes clusters on the cloud, your control plane still cost you money. So Nova has this concept called just-in-time clusters, where if Nova determines that, hey, none of the existing fleet of clusters are suitable candidates, I need a new cluster, then Nova will provision a just-in-time cluster. So for now, just-in-time clusters, we support them on all the major cloud providers. But for vCluster, it'll be awesome to try out how just-in-time would work with Nova.
Oh,
Um, I'm guessing that it would even be much more simpler to provision a just-in-time vCluster than a regular cluster.
yeah, looks like it. We can maybe look into it. And so, if I may understand, so there is a Nova control plane which sits in one of your cluster, and then you can connect OpenShift, some cloud cluster from GKE, EKS, and maybe a local cluster together. And then at the end, the control plane which you have from Nova will take care of those management.
It'll take care of workload scheduling, workload rescheduling. So instead of saying, hey, my workload X will go to red cluster, my workload Y will go to blue cluster, instead of having these static mappings. And what if the red cluster is out of capacity, then you have to manually reschedule your workload to a different cluster. So instead of saying that my X goes to red cluster, my workload Y goes to blue cluster, you're sending X and Y workloads to Nova control plane. And Nova dynamically figures out which cluster is the suitable candidate for the workload based on the workload's resource requirements and user defined policies. Does that make sense?
Yes, and can the user define policies like, for example, if a workload requires one GPU, so is it possible to define it through Nova?
Correct. Yeah. So you do not modify any of the workload manifests. So you take your workloads as is. So you say my workload needs X amount of CPU, Y amount of memory, and maybe I want a GPU shape. Z, right?
Mm.
So there are many schedule policies available in Nova. One of them is availability based scheduling. So when the user defines the schedule policy, the user could say, "Hey Nova, schedule this app to any available to a cluster where there are available resources." So then Nova would know, let's say you have one on-prem cluster with X amount of GPUs, and you have a cloud cluster with where you don't have any pre-provisioned GPUs that are already available, but the cloud cluster can expand to provisioning GPUs. So if these are the two clusters in your fleet, if your on-prem cluster is out of capacity of GPUs, Nova will dynamically schedule your workload to the cloud cluster where GPUs are available.
Oh, awesome. So I think this can also open up a use case of workload migration. For example, if you want to migrate your workload from expensive cloud provider with a lot of control plane and revamp pricing to your bare metal servers, which you have started to run with bare metal vCluster, then that can be possible. So is this a very
Exactly.
common use case?
Yes, that
Everyone?
is a really good use case. And in fact, one of the exercises that I hope we do today is to see the dynamic migration. Nova also has a what if scenario analysis where, based on it can figure out run what if analysis on how much it would cost for this workload to run on cluster Y versus cluster X. So that is also super valuable. If in addition to availability based scheduling, if you're very cost sensitive, you can think along those lines as well.
And how does Nova understand the pricing? So you need to manually feed it, or is there any policy for that?
That's a really good question. So for the cloud providers, the pricing information is available. So Nova sources it. Nova uses a product called Luna that is also from Elotl, where
Oh,
we have the pricing info for a single cluster for different types of nodes. So for the public cloud provider, it is available publicly through APIs that Nova is already making use of through Luna. For on-prem and other neo environments, we'd love to ingest it in a whatever API fashion, if possible, that the on-prem provider makes available. Or if the user has a static way of saying, "Hey, for I just bought these whole bunch of NVIDIA GPUs, and this is the pricing list," we could look into ingesting that format as well.
oh, that makes sense because a lot of organizations are moving towards more bare metal and buying a stack of node pools for their GPU in-house infra. So having a way where you can understand the pricing and configure locally as well as on cloud, that brings in a very useful gap. For example, suppose you have a certain type of workloads running in the cloud, but you need more powerful GPUs, which you already have. Or for example, you're running the important workloads locally in your bare metal servers, and when there is a spike in demand, you want to move those excess workload in the cloud. So that is a use case which we can target and save the already infra cost which we have occurred by procuring infra, as well as on new infra.
Yeah, the exact use case we are going after. It's the second one you mentioned is the cloud bursting, where you have on-prem capacity and you want to burst to public cloud. This The first use case you mentioned is the reverse of cloud bursting, where you are on cloud but you want to burst to on-prem. So both are very valid use cases for AI workloads that are extremely SLA sensitive, where you
Mm,
have to procure the resources in a highly time sensitive fashion.
of course.
Yeah.
And with Nova, what are the things that customers are requesting next? Like there might be a lot of demand for different type of workloads and stuff. So what are the most two, three features that your customers are like, if we have this kind of capability, it will help us to increase and optimize cost?
Yeah, for sure. So with Nova, since we are a very small team and an early stage startup, every feature that Nova has is a result of some kind of an ask or an input from the market. So Nova has evolved as a general purpose fleet manager with a focus on AI ML workloads. So, for example, the ability for Nova to provision virtual clusters would be super valuable, and that's why the integration with vCluster was an exciting exercise for us, where you do not have these heavyweight control planes that Nova is managing, but simple vClusters could be a good fit for customers that want to have multi-tenancy for their on-premise fleet of clusters that they want to use to build out internal AI/ML functions and features to serve their internal business units. So management of some kind of a namespace isolation for supporting multiple business units is actually something that we hear quite a lot, and that's why we are excited about the work being done at vCluster. Cost-based scheduling is something that's going to we actually published a blog post just yesterday on
Oh,
the
okay.
what if analysis, so that is something that customers are interested in as well.
Yeah. And so I will introduce vCluster a bit more because we talked about vCluster a lot of times. And then I think you have some slides that we can go through to understand Nova in bit more details and the demo, which a lot of people might be waiting for. So vCluster has been evolving a lot. So initially we were focusing on namespace based isolation for your workloads. That was a virtual cluster per namespace based approach. So you could have a virtual cluster by having linked to it a namespace. So your CRDs and everything would be isolated inside of a control unit, which you can define and give to your developers. But with new releases, we have launched private nodes, auto nodes. So you can have vCluster as a way to create your own private cloud. And on a sneak peek, we are also launching vCluster standalone coming in the next week, where you can have a whole distribution with vCluster. So covering the whole multi-tenancy spectrum. So we started and we are focusing on different areas. For example, when you require just simple isolation between a simple host cluster, you can do that. Or else when you require isolation that goes through different providers, like with the concept of private nodes, you can do that as well. So yeah, a different approach and a different spectrum covering any requirements you have. So focusing on the Nova plus vCluster combo, would love to see you what details you have.
Yes, for sure. Since the setup will take a bit of time to run, should we kick off the setup script before switching to
Yeah,
the
sure.
slides? Yeah.
Yeah, sure, sure. So what I will do is I will start sharing my screen,
Mhm.
and 1 second. Mm, So yeah, so I have my terminal with me, which I will expand, and I think there are a couple of prerequisites that we need to take care of. So first one is Docker, and then for this specific demo, it's kind, but you can do this across any cluster you want. Maybe it be private cloud or public cloud or your local, like in this example. And then of course kubectl for managing your clusters and everything, and then other two specific requirements. Next, I think Nova CTL. Can you share what
Yes.
is Nova CTL?
Yeah. NovaCTL is installed as is a CLI that allows you to easily create Nova control planes. It works as a kubectl plugin, so it's super easy to do to use NovaCTL through kubectl. So it's very similar to the vCluster CLI as well. Um, Thanks, Hrittik.
Yeah, so we have already gone through the steps, so it's very simple. You just download it and then add to your path, and you can add the plugin as well. So we have done all those steps, and then I think you can try Nova on kind, but as this will focus on how you can create isolated virtual cluster units with that. So you should have vCluster installed on your local machine, the CLI, which you can do through the brew step. and then we'll just check the Nova CTL version once, and it is a 1.3.9. And then we need to add couple of environment variables, right?
Yes, correct. Yeah, these environment variables will make sure that the trial environment is set up correctly. So we want to define what are the names of the workload clusters and what are the names of your V clusters, and what namespace do you want Nova to be installed, Nova and related components to be installed in, etc. So it basically makes your life super easy for setting up the trial environment instead of editing a whole bunch of scripts.
Of course. So let's add this so we can have those all. And then I think we need to use the following script. So let's clone this repo on our path, and we can go here, and so the setup v
vCluster.
yeah is a script which we will run right now, right?
Yeah. And I'll go into what kind of environment this provisions in right now, because we wanted to kick off the setup right now, because it setup takes a couple of minutes to provision the whole environment, and we didn't want you all to be waiting while that was being done.
Of course. So let's let it happen in background. Till then we can go through the slides which
Yes.
you have.
Yeah.
So,
Yeah. Can you see my screen?
yeah, we can.
Yeah. So, Hrittik, this is related to the question you asked, which was who is the target audience for multiple clusters. Originally, we thought that it was large enterprises with large number of clusters, but like you called out, it's super easy to set up virtual spaces for multiple teams and multiple products using vClusters. So we are seeing a lot of smaller business units and smaller companies that have this large cluster footprint. So the moment your number of clusters or vClusters expands to more than two or three or five, then you need a fleet manager. Does that make sense?
Of course.
Mhm. So Nova is a multi-cluster orchestrator. You talk to it using the regular Kubernetes API. All your workload manifests, instead of being sent to individual Kubernetes clusters or vClusters, you send them to the Nova API server. You do not change, modify your workloads in any shape or form. The only thing you add is the schedule policy. The schedule policy defines where your workload manifest lands on your fleet. Traditionally, Nova supported all the hyperscalers like AWS, GCP, Azure, OCI, etc. So the managed clusters could be EKS, GKE, AKE, OKE. As of today and moving forward, the neo clouds are also a really good target clusters for Nova because of the GPU requirements for AI ML workloads. Of course, on-prem clusters, OpenShift, and other any Kubernetes distro can be ingested by Nova. And we validated this week that Nova can ingest V clusters. So yay about that. Super exciting to see that Nova can manage a fleet of V clusters as well. I'm going to pause here to see if the architecture makes sense, Hrittik.
Yeah. So I have
Mhm.
a question on the architecture. So I think the schedule policy is a Nova level object because it defines everything, right?
Correct. Yes.
Yeah.
Yep. Yep. So schedule policy is where Nova's power lies. Schedule policy is a kind of Kubernetes object which has two key sections to it. It defines which resources does the policy govern using labels and namespaces. So you could say apply this policy applies to all objects in this namespace, or you could say this policy would apply to all objects that have this label. So so the first section defines which resources would this policy govern. The second section defines which clusters should these resources land on. The clusters could be selected using labels, inclusion exclusion list. These are basic selection criteria, or you could have more complex selection criteria, like the cluster would be a cluster that has available resources that can take on this workload. Or you select the clusters, you can have a schedule policy that says fill up these clusters, red clusters, before spilling over to blue clusters, etc. I'm going to pause here to see if these two sections of the schedule policy make sense.
Yeah, yeah, of course, because you need to make sure either resources are there or you have specific geolocations or labels that you are matching. So Nova kind of does everything you require, but across different clusters.
Yes.
So you have a way to interact with many clusters at once.
Correct. Yeah. So the first section is which resources does the policy govern, and second section is the which clusters should it land on. And this is where the dynamic scheduling and rescheduling would come into picture. So in the demo, what we are setting up is we are setting up two V clusters. So going back to this diagram, we'll have managed cluster one is a V cluster, managed cluster two is a V cluster as well. In the demo, each of these V clusters are hanging out on their own kind clusters, but they could be co-located for all means and purposes on a single kind cluster. Nova control plane itself is a Kubernetes object. It is comprised of etcd and a bunch of CRDs and API server. Nova control plane can run as a Kubernetes workload anywhere. So it doesn't require any special criteria for being hosted anywhere. It's a regular Kubernetes workload and it can run anywhere. So instead of making your workloads talk to each of these individual V clusters, what we are going to do is we're going to target the workloads to Nova's API server. So we are going to schedule the workload to Nova control plane, and we'll define some interesting schedule policies which dictate where the workload is landing. Does that make sense?
Of course.
Mhm. Some of the interesting use cases is initial placement of workloads. So when your workload is originally scheduled, you might want it to land on a cluster which has available capacity for the workload. So that is the initial placement of the workload scenario. So Nova can take care of initial placement, where you can define a capacity based scheduling policy, or you can say spread my workload across multiple V clusters. For example, you might have logging, monitoring, analytics components like Prometheus or FluentBit or any of the LMA components, where you want your Prometheus version X to run on all red clusters. So you want all red clusters to run Prometheus version X. So you can say, hey Nova, here is a schedule policy that spreads Prometheus across all red clusters. So Nova will spread your workload across all red clusters. You can also have for high availability, or to make sure that if you have an AIML workload that is super SLA sensitive, you might want the deployment to be spread in a certain fashion using percentages. For example, you might say, I want 20% of my workload deployment pods to run on red clusters and 80% to run on blue clusters. So Nova will spread your deployment pods across multiple clusters as well. So I'll pause here to see if the initial placements basic scenarios make sense.
Yes,
Mhm.
because both of them are a common scenario. So
Right.
initial ones make.
Yes, another initial placement scenario that's super interesting in the context of AIML is fill and spill. This was what Hrittik, you and I were talking about earlier. Is you might have on-prem capacity that you want to fill up and then spill to public cloud or neo cloud, or you might have neo cloud capacity. You might have a CoreWeave cluster, and if you're out of capacity on CoreWeave, you might want to spill into on-prem. So the fill and spill is also an initial placement policy that is really valuable for AI ML workloads. Does that make sense?
Yes,
Mhm.
as we were discussing previously.
Yep, yep, yep. The second set of scenarios are rescheduling. So once you're past initial placement of the workloads, um, what if the workload load changes on as the months progress into years? What if the workload load changes on your target clusters? Nova also takes care of dynamic rebalancing. So if you want to upgrade your red cluster, you might want to drain all the workloads on red cluster and move them to blue cluster. Nova will be able to help you take care of that. It can also move workloads based on application resource needs. For example, your AI/ML app is doing really well and it has a lot of users internally, and you might want to change your replica count from 50 to 100, which means that the 15 new pods cannot fit on your red cluster and they might have to go to a blue cluster. That's a rebalancing workflow. And like you called out, Hrittik, bringing up clusters on the fly. If your existing clusters are fully loaded and you might want to bring up clusters on the fly, if your load increased, Nova can help with just-in-time clusters as well. So this is the second set of use cases for once you're past initial placement, it is the workload rebalancing workflows. Do they make sense?
Yeah, and as well, I think migration also kind of falls into this space. Like if you want to forcefully migrate your workloads from one provider to a different, so I think it also falls in this scenario, right?
Yes, exactly. Yeah. So if you want to, this is actually a big concern for people, enterprises who have their traditional footprint on the traditional hyperscalers like AWS and Azure, and they got new credits or they got huge discounts with CoreWeave, and they want to adopt CoreWeave. How do they migrate without bringing the application down? That is the workflow where Nova is really helpful.
Yeah, of course, and
Mhm.
as well as posting as well, right? As we were discussing, when organizations are purchasing DGX and all those nodes for a private AI cloud internally.
Yes, correct. Yeah, yeah, absolutely. Yeah. And once your application has been placed and rebalanced, one of the biggest asks for enterprises, the product leaders, is you need to take care of disaster recovery and high availability of the app. Again, Nova is helpful with DR automation because you don't have to pay for and maintain a DR standby site. Nova will take care of that automatically for high availability and disaster recovery. So, meeting these enterprise readiness requirements is also a work stream where Nova is helpful. Does it make sense?
Yeah, would love to know what does Nova DR automation does. Like, is it? Yeah,
Yes. So when you have two workload clusters as as part of Nova's fleet, when you schedule your workload through Nova, you're telling Nova, "Hey, I want 10 instances of this app always on," right? And you might say that 80% of the app's pods, of the deployment pods, to keep it simple, let's say it's a deployment, and you say 80% of the pods of the deployments are on my primary cluster and 20% are on the standby cluster. So you always have pilot flame that's running on the standby cluster, and as soon as the red cluster, the primary cluster, goes down, because you have set the deployment to be containing of 10 pods, Nova will automatically increase the number of pods from 2 to 10 on the standby cluster. So you have your SLAs being met all the time. Does that make sense?
yeah, of course. That's an
Mhm.
awesome ability that we have.
Yes, yeah. So that way you don't have a manual intervention of trying to figure out, hey, my cluster went down. Let me spin up this standby cluster. And like we were talking about, just-in-time clusters could be really valuable here as well.
Yes.
Mhm. So let's do a quick check on how the setup is going.
I think the setup is done,
Okay,
but
cool.
let's check.
Mhm.
Can you see my screen?
Yes, yeah, awesome. So now we have Nova controlling two workload clusters, which should be the two V clusters that were provisioned.
Yeah.
Um, Let us see if Nova is able to see the. Let's look at Nova's fleet to begin with.
Sure.
Um,
So I think this is the command for that.
yes, yeah. Can we update the kube config? I actually have it as part of the README now.
Okay, sure.
Yeah.
And then the same command.
Yes.
So yeah, as we see, there are two V clusters that are being managed of 1.33 version.
Yep, yeah. So the names of the V clusters have some meaning to it. So I wanted to talk about it a little bit before we move on. So V cluster one is the name of the V cluster. The second V cluster one is the namespace in which it is running. And the third component is the kind workload cluster one. So that is the kind cluster it is running on. So the way the naming is structured for this trial is the vCluster, name of the vCluster, the namespace that is tied to the vCluster, and the kind cluster it is running on. Does that make sense?
Yeah.
Mhm.
So so as we have two kind clusters over here, so that's the reason we have two workloads, the kind one, kind two, right?
Yes, correct. Yeah. You can obviously deploy multiple vClusters on the same kind cluster. For this version of the trial, we have two separate client clusters.
Of course.
Yeah.
Uh, So
Um,
each V cluster is running in one kind cluster.
Correct. Yes. Yep. Yeah. And Nova is managing the fleet of two V clusters. Um, so the next step is it would be good to create a simple schedule policy where Nova would spread the pods of an Nginx deployment in a 20-80 percentage split across the two V clusters. Shall we try that schedule policy?
Yeah, sure. So as we can go here, so the API version is Nova, and the schedule policy is over here, right? The
Correct.
topology page,
Yeah.
80% on the second one and 20 over there.
Correct.
Yeah,
Yes.
pretty standard camel. So we will try this.
Yeah. So once we let us create the schedule policy on Nova. So
Yeah.
now the schedule policy is created. So if we look at the schedule policy again, it has this interesting resource selectors section, which says match labels at the bottom of it, the last section.
Okay.
Yes. So we are saying this schedule policy will apply to all resources which have these label group policy nginx spread. Yeah, if that
Mm,
makes sense.
yes.
And also, yeah. Um, and the grouped by label key is also interesting, but let's move on and see and go through the next step.
Yeah. So let's inspect the new schedule policy.
Yep.
So yeah, as straight group policy 46 seconds ago, it's there.
Yep. Awesome. Yeah. So now let us create nginx deployment that would match the requirements of this policy. Before we do that, if we want to take a look at the example sample spread nginx app.
Yeah, let's do that. So as we were talking here, we have the labels, app,
Yep.
and Nginx spread.
Yep.
So yeah, group policy. Nginx spread and the app, so it matches our scheduling requirements, right?
Yes, yeah. So when we create this, because the schedule policy now exists in Nova,
Mm-hmm.
the moment you submit the workload, the Nginx workload to Nova, it is matching the schedule policy. The schedule policy will apply to the Nginx workload. So Nova will take care of scheduling the Nginx workload that honors the schedule policy, which where we are asking, hey, I want a 2080 split between vCluster 1 and vCluster 2. Does that make sense?
Yes. And what is the service account doing over here? So does Nova require a service account creation, or is it just
No, it's not. It's just the standard Nginx YAML file that we pulled off.
okay. So let's go and create this so we can
Hmm.
move on to next steps.
Hmm.
So yeah, pretty standard. So yeah,
So deployment is created in Nova. So now it will be interesting to see three things. So first is what does Nova look at, right? What is the Nginx deployment state according to Nova? What is Nginx state according to vCluster 1? What is Nginx state according to vCluster 2? So these are the three commands we want to run. What are the deployments? Hey Nova, what are the deployments? Hey vCluster 1, what are the deployments? What are the pods? And hey vCluster 2, what are the pods? So let's go ahead and run these three commands.
yeah.
So it
So
has 10 pods and they are in the process of getting ready. So let's look at the individual V clusters.
sure. So as V clusters are actual clusters, so you need to use their kube config over there
Mhm.
so that you can access. And if you are in a team setting, so you can give the kube config access to each of your individual team, so they can run their workloads over there and manage what's deployed by Nova.
Correct, yes. So you see that it has gotten
Mm-hmm.
two pods for this deployment. And let's look at the second one.
Yeah, 8. So
Yeah,
as
yeah. So we see that the Nginx deployment got split in the 2080 fashion. Let's give it a couple of seconds for the pods to come up as well. While we are waiting for the pods to come up, are there any questions about how the policy applied?
no, that was very simple. Like
Mhm.
as like it's so declarative that you can specify the topology value. So it is very simple. But I would love to know what type of other policies that are popular.
Yes. So this is a simple spread policy. There is capacity based scheduling policy where you say that I want to schedule the workloads that match this policy to a cluster which has sufficient capacity for the workload. So
Yeah.
this is very helpful. The capacity based scheduling is very helpful for AI/ML workloads in particular because GPUs are very scarce and also AI workloads are very sensitive to the kind of GPU. So you might say that for this model, I don't want to, I only want to use GPU shape X. I don't want to use GPU shape Y, right? So being able to, and the availability of these GPUs might be dynamic, especially in the neo cloud and hyperscaler environments. So when you say that, hey Nova, schedule my workload to a workload cluster that has sufficient capacity, then then the dynamic scheduling happens according to capacity. So capacity based scheduling is really popular. The schedule policy. The other schedule policy that's very interesting is fill and spill, which is I want to fill my sunk cost clusters and spill to my more expensive clusters. So fill and spill is also another interesting schedule policy. Does that make sense?
Yeah, of course.
Mhm.
As we discussed initially, so those type of policies will help you to figure out your infra requirements and focus on what you want actually.
Right.
Boss.
Yeah.
Yeah.
Yeah. Yeah. Let's look at Deployments, oh, it's still pending. So let's do one more thing while these things are starting up. Let's go ahead and edit the policy, the schedule policy, to change the replica count. So let's go and do the next step.
Yeah, this.
um, Correct, yes, yeah, in the interest of time, yeah. So if we look for 20, yeah.
Uh,
Yeah.
yeah,
So feel free to change it to anything else.
like 50-50.
Yeah.
Yeah,
Okay. So now if we look at the deployment,
yeah, like the scheduling is happening, but I
right.
think because of some reason, I don't. We can check later on.
Yep. Yep.
Uh,
Yep.
uh, so yeah, so as defined, it went to 0 2 to 8 to 5 to 5.
Right. 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 Yep. Yep.
Yeah, and
So let me share with you the other scheduling policies while we are waiting on those.
yeah, it might be because uh, like not something related to Nova or vCluster as well.
Correct. Yes. Yep. So if we set the context to vCluster 1 or 2 and look at the deployments in yeah.
It's image Polera.
Okay, okay. Can we look
Yeah,
at the logs of
yeah, sure.
events? Yeah.
I think it might be an issue with the um, full secret on my end.
I see, I
Uh,
see.
yeah, because I think authentication of the container history or some error like that.
I see, I see, I see.
But overall, the most important part is that the scheduling is happening, even though there is some error with the image pool.
Right, right, right. Yep.
Yeah,
Yep. So the thing we are most excited about is that having Nova manage vClusters is a really valuable asset and addition for our customers, because provisioning, managing vClusters is a lot more simple than provisioning regular control planes and accounting for regular control planes. And most of the time, the need for a new cluster is team management and namespace management. So being able to provision vClusters on demand and manage vClusters as part of Nova Fleet is going to be a huge value add for our customers. So we are really grateful that it was super easy to ingest vClusters as part of Nova Fleet. It literally did not take a single edit to anything on our end. So vClusters, it's a testament to the quality of the product that it was so easy to ingest vClusters.
yeah, of course, and that is what vCluster is all about. So you can, it's a conformant cluster. So you can do whatever you are doing in your regular cluster, maybe it be in private cloud or public cloud or on your local machine, and you can migrate the workloads over there, or the vice versa, or you can use vCluster without any changes required to your actual host different cluster. And apart from that, you also get capabilities like, for example, if you have an ingress controller on the host, and if you want to use the ingress classes from the host to the virtual cluster and sync back the ingresses from the virtual cluster to the host across different, that is also possible, overall improving the overall agility uh, and the most important thing, the workload optimization and the IT requirements. So everything is centralized, including if you are applying policies like Kaizen or something across your entire fleet.
For sure. Yep.
Yeah. So yeah, I think apart from that, uh, the issue was of the image container registry. As I'm looking at it, so there is some proxy issues, so some network issues that is happening. That's the error.
I see.
But
Mhm.
but apart from that, the most important thing, the scheduling is happening as expected. Image might be pull error, but because of the new limits there are. But yeah, and thank you so much for demoing this awesome product to the vCluster community, and excited to see what's coming next with Nova.
Yeah, thanks so much, Hrittik. This was really exciting to see vCluster work with Nova, and we hope we can bring the value of vCluster and Nova to the enterprise AI initiatives and accelerate the AI initiatives go to market using the two products together. So, looking forward to bringing the value together as well.
Yeah, and before we leave, I have a question for you. So, are you coming to KubeCon North America?
Yes, we have a panel at AI Day, so I understand you all have a booth at AI Day as well. So please come talk to us at AI Day. We'll be there.
And what is your panel about?
The panel is about AI infrastructure trends for enterprises. So I have pretty cool people from both the power users as well as the vendor ecosystem in the AI enterprise space that are going to answer some of the questions that are related to enterprise adoption of AI. So pretty excited about the panel.
Yeah, sure. We'd love to see you there. And as you shared, we have a booth over there. So I will be in the booth. We have a talk as well. So excited to meet at KubeCon and maybe talk about Luma in the future edition.
Yep, yeah, for sure. Yeah, that sounds great. Yeah, thank you so much, Hritik. This was really awesome to have you try out Nova plus vCluster.
Yeah, thank you for showing around and making time for the show. And see you around.
Yep, see ya. Bye.